So here is a short video on reasoning and aptitude questions or subtopics in short for DSSSB, JE and A. This is more of a revision video. So the first question was from number system. It is one of the PYQs from DSSSB. Some of the first 20 natural numbers. So for the series of sum of natural numbers, which includes sum of natural numbers, sum of square of natural numbers and sum of the cube of natural numbers from 1 to n, it has got the formula. For sum of the natural numbers, it is n into n plus 1 by 2. For sum of square of natural numbers, it is n into n plus 1 into 2n plus 1 by 6. And for sum of cube of the natural numbers, it is n into n plus 1 by 2 whole square. That is, this formula is simply this formula's whole square, whereas this formula is a bit different. N into n plus 1 times 2n plus 1 by 6. Similarly, we have a formula for sum of the odd numbers starting from 1, that is 1 plus 3 plus 5 plus general expression of an odd number. It is given by n square. For example, if I have 1 plus 3, then n will be 2, that is 2 square. When we have 1 plus 3 plus 5, this is 3 odd numbers, it will simply be 3 square. Similarly, 1 plus 3 plus 5 plus 7, this will come out to be 4 square. Hence we can use the general formula n square when it is odd numbers. For even number, it is given by n into n plus 1. If I have to calculate 2 plus 4, it would be, since these are two terms, so n will be 2, 2 into 2 plus 1, that will be 6, which indeed is 6. Then we have remainder as one of the subtopics. For example, we have 1421, 1423, 1425 over 12. Now these notes are primarily derived from the Ashutosh Sharma sir from Made Easy. So if you have studied from him, you will most likely notice that 9 out of 10 problems or formulas or descriptions are from his notes only. So if you have studied from sir's notes or sir's lecture, you will find it, all of them, in here. So this is just a revision video. Then we have this problem where we have to find out the remainder in this form, where we can have multiplication, addition also, or subtraction also. The concept is that whatever the relation is in between the original numbers, here it is 1421, 1423, 1425, the remainders for each the number, like if we divide 1421 by 12, the remainder comes out to be 5. For this comes out to be 7. And similarly, if we divide 1425 by 12, the remainder comes out to be 9. The relation that is being followed here with the original numbers will also be followed by the remainders of them. And once we multiply these remainders, the coming number in this case will have 63 times 5, that will come out to be 315. Then we have to divide it by the original dividend once again and check the remainder. Whatever the remainder will come, that will be the answer. In this question, the numbers are increasing by 2, as you can see, 2, 1, 2, 3, 2, 5. Therefore, the remainder also decreases by 2. You don't have to check all of them individually. Once you have to check what is the remainder for 1421, and if the remainder comes out 5 and the next number is just plus 2 and the next number is just plus 2, you will simply, instead of doing it individually, add plus 2 in the remainder, add plus 2 in the next remainder. For this particular problem, this may not be happening for all the cases here. As it says in the cloud, that if the sign between the numbers is multiplication, this same sign will come between the individual remainders as well. Had it been a plus addition, the sign would have come in the remainders as well. As you can see, dividing 1421 by 12, the remainder comes out to be 5. And when we multiplied their individual remainders, the answer comes out 315. But this is not our actual answer. We have to further divide the remainder or the multiplication of these remainders to the original dividend, that is 12, and after doing this the remainder comes out 3. That is our final answer. So for this question the final answer is 3. Similarly, we have this question where we can check the remainder dividing 176 by 13. The remainder comes out to be 7, and the next two numbers are just different from each other by an addition of 2. Therefore the remainders will also be having a difference of positive 2 only, and we'll simply be multiplying all of them individually because the original numbers have multiplication between them. So it becomes 7 times 9, 63 times 10, that becomes 630. We'll simply divide 630 by 13 and the remainder will come out to be 6. Then we have this format where it is often 10 to the power 10, 10 to the power 100, 10 to the power 1000 and 10 to the power similarly we often get 2 to the power 100 or 1000 divided by 15, and we have to find out the remainder in such cases where high powers are given, especially in terms of 100 or multiple of 10. What we have to do is we try to find out the individual remainder as 1, and once that comes out we simply have to power or express 1 in terms of the given powers, and the question becomes as simple as possible. But for that we have to try to get the remainder as 1, and whatever the relation will be in between those numbers will be followed by the remainders individually also. For example, if in here it would have been times multiplication, we would have done the multiplication the remainder of individual numbers as well. So you can see for the first the dividend is 3. First we'll try to divide 10 by 3. The remainder comes out to be 1. Therefore we'll simply use this remainder in the place of original number and use the original powers or exponents the number had. So that will become, since all of these base numbers are 10, the remainder will be 10 for each of these numbers. So 1 to the power 10, 1 to the power 100, 1 to the power 1000 and 1 to the power 10,000. The answer will simply be 1, 2, 3, 4, and then after getting the number will further divide by the original dividend, hence the remainder will come out to be 1. Hence the correct answer is 1 only. Similarly, we have this question, 2 to the power 600 divided by 15. It is a DSSSB PYQ. In such question again the approach is to get the remainder as plus minus 1. So we have 2 to the power 4, or we also have to do one thing, that in this case we have 600. We try to make the exponential power as 100, 150 or something like that. Okay, so in this case what we did is, and since we have to get the remainder as 1, we'll check 2 to the power 4 divided by 50. We won't be getting 1. 2 to the power cube 8 won't be getting 1 as remainder. 16 by 15 we do get the remainder as 1, so this will work. So we'll simply try to break this expression into 2 to the power 4 or 150 divided 15, and whatever the remainder comes out in between them, that remainder will be kept in the place of original number and we'll use the exponent the power, and hence in this question the answer will simply be 1 to the power 150, which is the correct answer. Now here is another question where 2 to the power 100 is divided by 7. Now let us see, we'll try to bring the remainder as 1. Let's see, we have 2 to the power 2 is 4 divided by 7. We will not be getting 1 as remainder. 2 to the power 3, that is 8 by 7, immediately gives us 1 as the remainder, so we'll be using that. Now this is 2 to the power 100, so we have to divide the powers in such a way that it becomes easy for us. So what we'll be doing is 2 to the power 3 to the power 33, that will become 2 to the power 99 times 2 to the power 1, that becomes the original number 2 to the 100 divided by 7. So this is another case of this expression is another case of where we have two numbers. One is 8 times 8 to the power 33 and the other one is 2, and we'll be finding the individual remainders in between these numbers and simply multiply them. Okay, let us see. We have 8, the remainder comes out to be 1 to the power 33 and times the number, so this becomes 2, hence the answer is 2. Let's see another. So this is a different subtopic where sum of three consecutive even number is 90 and we have to find out the largest number. So three consecutive even numbers will always be represented by 2n, 2n plus 2, 2n plus 4. Since their sum was 90, we'll use this expression to find out n will come out to be 14, and see, since we have to find out the largest among them where 2n plus 4 is the largest, we'll simply put n equals 14 and the answer will come out to be 32. Now there's another shortcut for these types of question. It says for any odd count of consecutive numbers, they can be odd also, they can be even also, and since the count has to be odd, that means if three even numbers are added, if three consecutive odd numbers are added, something like this, so the average of them is always the middle number. That it means all of these numbers combined divided by 3 will be equal to 90, which should be equal to the middle term, that is 2n plus 2. That is, for this question we could have simply equated 90 equals 2n plus 2. My bad. The middle number, the average is always exact middle number. What it meant was that the middle number 2n plus 2 can be written in the form of sum, which was 90 divided by the count, where the count was 3 consecutive numbers. My bad. In this case, what we would have done is that we would have equated 2n plus 2, that is the middle number, equals to the sum of these numbers divided by the count of those numbers, that is 3. Hence, solving this would have given us the largest number or the middle number. And also, the concept is that the largest number is always the middle number. Okay. Sorry, largest is not the middle number, my bad. The largest number will be the last term only, of course. Here is another question where we have to find out the remainder. In this question again, where we have to try to get remainder in the form of either plus 1 or minus 1. As for this example, we have 80 by 9, the remainder comes out to be 8, but that 8 can be written as less 1, because had it been 9, just plus 1, 9 divided by 9 gives us no remainder, or it easily gets divided. There won't be any remainder, because 81 is 9 times 81, there is no remainder. So this expression is also expressed in the form of minus 1. Similarly, we have 27 by 4. We know had it been plus 1, that is 28, the remainder would have been 0. So in this case the remainder comes out 3, but that 3 can also be written as the remainder as minus 1. Similarly, we have this question where we know the next number that can be divided is 28. So in here the remainder comes out to be how much? Remainder would be 4 but 3. Or we can also write it in the form of 21 plus excess of 4, because 21 was easily dividable. So it has an excess of 4 but with respect to 21. So we can write 25 by 7 is RE minus 3. That is, there is a deficiency of 3 or an excess of 4. Deficiency of 3 is for 28 with respect to 28 from 25, and there is excess of 4 with respect to 21. Now here is an example where 20 to the power 20 divided by 9, we have to first use the base number. The remainder comes out to be 1 to the power, the original power, the answer will be 1. Similarly, we have 18 by 19, it is less than 1 from 19, so we'll use minus 1 in here, minus 1 to the power 19, the original power, and the answer will be, since it is an odd power, for minus 1 it will come out to be minus 1, but our answer is not minus 1, our answer is 18. Hence the correct answer is 18. Here is another question which is worth mentioning. It is 2 to the power 1 by 6, 1 to the power 3 by 4, and minus 1 to the power 1 by 2. The simple trick is, first of all, perform the operation with the base numbers, that is 2, 1, 1, and keep the original operations, that is 2 plus 1 minus 1, that will come out to be 2. And for the fraction part, now do the same, that is 1 by 6 plus minus 1 by 2. The answer will come out to be how much? For the base it was 2, and for these fractions it was 5 by 12. So the answer will be combining this and this, that is 2 to the power 5 by 12. And now we have LCM and the HCF as a subtopic. Here is one example where the red light flashes every 3 seconds and the green light flashes every 4 seconds. And if it is asked that at what interval do they flash together, we simply have to take the LCM of their timings, individual timings. It says that since it is flashing every 3 seconds, you see it will flash 3, 6, 9, 12, similarly 24, 36, and it is when both of them will reach 12 seconds they will flash together. 24 they will flash together, 36 seconds they will flash together. So we simply do instead of doing all of this long way or traditional way, we'll simply take the LCM of these two timings, 3 and 4, that will come out to be 12 seconds, or we can write it in the form of 12k, where it says that they will flash together in multiple of 12 seconds, that is 12 times 1, 12 seconds, 12 times 2, that is at 24 seconds, 12 times 3 at 36 seconds, and 12 times 4, that is 48 seconds, they will flash together. Now there's another example which says if the red signal flashes 3 times in 2 minutes and the green signal flashes 5 times in 3 minutes, how many times will be they flashing together but in 1 hour? 1 hour is 60 minutes, 1 hour is also 3600 seconds. We'll see about it. First of all, we'll check. We'll be doing it in 2 ways. That since it is mentioned that in 3 times the red will flash, or in 2 minutes the red will flash 3 times, and in 3 the green will flash 5 times. So we'll check that in how much time duration they flash one time. So one flash at the rate red will be what? 120 divided by 3, since 2 minutes is 120 seconds, so 120 divided by 3 will be 40 seconds. That means one flash of the red will be coming in 40 seconds, and 80 seconds there will be 2 flash, and 120 seconds, which is 2 minutes, there will be 3 flashes or 3 times. Similarly, dividing 5 by 180, we get in 36 seconds there will be 1 flash of the green. So since both are individually flashing at a time duration of 40 seconds and 30 seconds, we just have to take the LCM of these flashes and check when will be they flashing together. The LCM comes out to be how much? 360 second. That is a multiple of 360k. That is 360 second times 1. 360 second is how much? It is 6 minutes, right? And then 360 times 2 is 726 seconds, which is how much? Which is 12 minutes. This is 36k sec. So for 1 hour, which has 3600 seconds, how many times will they be flashing together? We can write that they will be flashing in a multiple of 360 times k seconds. We have to equate it into 3600 seconds. Since क्वेश्चन ने हमसे ये पूछा था कि 1 घंटे यानी 3600 सेकेंड में वो कितनी बार फ्लैश करेंगे, तो हम इन दोनों इक्वेशन को इक्वेट करेंगे. सो k will become 3600 over 360, that is 10 times they will be flashing together for a time duration of 1 hour or 60 minutes or 3600 seconds. So there is another formula which gives us the LCM of things which are in fraction. That is, if we have to find out the LCM of A by B, C by D, E by F, it is equals to LCM of the ACE and HCF of BDF. Similarly, highest common factor, the numerator goes, HCF comes in the numerator when we are finding out HCF. Similarly, when we were finding out HCF, the numerator will have the LCM and the denominator will have HCF. Similarly, for HCF, the numerator will have HCF and the denominator will have the opposite. Okay. So for the previous question, we can write that the time of the red signal or time of the green signal as how many time, in how much time they are flashing one time. That is, for red it will be 2 by 3 minutes, for green it will be 3 by 5 minutes, one time flash. So we'll simply be taking the LCM of this ratio or fraction form. That is, since we are taking LCM, numerator will have LCM that is 2 by 3, 3 by 5. We'll be taking LCM of 2 and 3, and then we'll be taking HCF of 3 and 5. So LCM of 2, 3 is 6, HCF of 3 and 5 is 1, since these are co-prime numbers which have highest common factor equals 1. So 6 minutes. Therefore, the LCM 6 minute means they will be flashing together as a multiple of 6 minutes, 6k. So we'll be equating 6k equals to the time duration they asked. They asked one in how many time, how much times will be they flashing together in 1 hour, that is 60 minutes. That is 6k will be equated to 60 minutes. K will come out to be 10. So in this another method we are using minutes, but in the previous question we were using seconds, which was again a bit longer. Hence we tried both ways. This is a bit shorter way, so answer will be 10 times. So here is a chart of flow chart of the key terms which are given in question, through which we have to get a signal that the question is eventually going to ask about the lowest common factor. If the question asks the first time the least of all, the minimum value, if the two persons meet again, if the two clocks are reaching simultaneously, if something coincide, if something is repeating every 2 seconds, 2 minutes, so all of these terms are for lowest common factor. Now here is another question where highest common factor of two numbers is 24 and sum of the two numbers is 144. What is the combination of number for this given question? So HCF of two numbers is 24. We can write the numbers as 24x and 24y, and sum of the two numbers as 144. We'll be simply doing the mathematics. 24 times x plus y is equals to 144, then x plus y comes out to be 6. Now even though this equation will be followed by 1 5 also, because 1 plus 5 is 6, 2 plus 4 is 6, 3 plus 3 is 6, but we also have to check whether the highest common factor for these numbers is 24 or not. Let us see. For 1 and 5 the highest common factor is 1 and they are co-prime. For 2 and 4 the highest common factor is 2, so the highest common factor is not 24, so this question is wrong. Let us see. For 3 and 3 the highest common factor is 3, so this is also not going to be correct, so the correct answer would be 1 5. Now what were the numbers? First number was 24 times 1, that is 24. The second number was 24 times 5, that is 122, hence their HCF is 24. Similarly the key terms for HCF is as maximum as possible, as heavy as possible, as largest as possible, as highest, whereas in LCM it was as lowest as possible, as minimum as possible, as smaller as possible, something like this. Here is another question based on the HCF. It says 4 metal rods of length 78, 104, 117, 169 have to be divided into parts of equal length. Further, each part is as long as possible. So we have to find out that how many how many parts can we divide into these 4 metal rods that will be of equal length, and that will be the maximum length in which we can divide these metal rods of length 78 units, 104 units, 117 units and 169 units. So first of all, as I said, as long as possible is HCF. So we'll be taking HCF of all these numbers. One can see 13 square, hence the HCF has to be 13. So we'll be dividing all these numbers by 13, or we can write them in the form of n1 into L, n2 into L, n3 into L and n4 into L. क्वेश्चन बेसिकली हमें ये बोल रहा है कि ये एक ओरिजिनल रॉड है जिनकी इतनी लेंथ्स है, हम मैक्सिमम कितने पार्ट में इन 4 रॉड्स को डिवाइड करें कि हमें एक इक्वल लेंथ की रॉड मिले और मैक्सिमम नंबर हम निकाल सकें, वो हमें देखना है कि कितना निकलेगा. तो इस वाली से हम मैक्सिमम कितनी निकाल सकते हैं? पहले हमने HCF निकाला, 13 हुआ. वी हैव, और हमें क्योंकि सेम लेंथ की निकालनी है हर एक ओरिजिनल बार से, सो विल सिंपली राइट n1L, n2L, n3L and n4L. यहाँ पर L वो कितना आ रहा है? 13 यूनिट्स. सो इन सबको डिवाइड करेंगे तो n1 आएगा 6, n2 आएगा, यानी कि 6 रॉड में 13 यूनिट की 78 वाली ओरिजिनल बार से निकालूंगा. उसी तरह 8 बार में 13 यूनिट की 104 वाली ओरिजिनल रॉड से निकालूंगा. उसी तरह 9 यूनिट्स में 13 मीटर की बार की इस 117 वाली ओरिजिनल बार से निकालूंगा. So total of these will be 36 rods, which can be manufactured from these original rod which were of different length. This was simple. Here is another question which says LCM of two numbers is 180 and their HCF is 6. If one number is 30, find the other. Let's solve this question. So here's the question. For such type of questions where LCM and HCF is both are involved along with two numbers, the concept is that first number times second number is equals to LCM, lowest common factor, into the HCF of these numbers. So for this question, what do we have? We have one number which is 30. We have to find out the other number, let it be x. LCM is given as 180 and the HCF is given as 6. So 30, that will be 6, x becomes 36. Therefore the two numbers were 30 and 36, for which their LCM was 180 and their HCF was 6. Since we can write the number as 6 times 5, the other number as 6 times 6, therefore the highest common factor was 6 only. Here is another statement based result from the profit loss chapter. It says if two articles, let us say this was a pot, another pot, they both were sold at a common selling price. Let us say both were sold at a common selling price of 100 rupees only each. One is sold at a profit of P%. Let us say that fixed profit is 20%, and another came at a loss of P%. Then effectively there is always a loss. यानी कि ये बोल रहा है अगर दो आर्टिकल्स हैं, दो चॉकलेट हैं जिन्हें मैं एक कॉमन सेलिंग प्राइस पे बेच रहा हूँ 100 और 100, और मुझे एक चॉकलेट पर जो है प्रॉफिट आ रहा है P% का प्लस P, और दूसरे पे लॉस आ रहा है माइनस P% का, तो इफ़ेक्टिवली मुझे हमेशा ही एक लॉस होगा, और उस लॉस की वैल्यू दी जाती है इस फॉर्मूला से 2p स्क्वायर टाइम्स s हमारी सेलिंग प्राइस है, P हमारा प्रॉफिट परसेंटेज है. सो इट इज़ 2p स्क्वायर डॉट s मल्टीप्लिकेशन over 100 square minus P square. We will get the loss in value, and if we have to find out loss in percentage, that is given by simply P square over 100. And similarly यहाँ पर तो पीछे वाले केस में सेलिंग प्राइस था, we were selling at a common selling price, we were selling at a common price. In this case we have bought them at a common price. Let us say we bought 2 avocados at a common cost price of 100 rupees. I sold one at a profit of P%. Let us say I had I sold it at 120, and the other I sold at a loss of how much? P%. Then अगर 20% एज्यूम करते हैं तो that will be 80. यानी एक एवोकाडो को मैंने बेचा 120 पे, इवन दो मैंने ख़रीदा 100 पे. दूसरे एवोकाडो को मैंने बेचा 80 पे, इवन दो मैंने खुद उससे 100 पे ख़रीदा. डैट इज़ मुझे प्रॉफिट भी हुआ 20% का और लॉस भी हुआ 20% का. तो इफ़ेक्टिवली ना तो मुझे ऐसे केस में प्रॉफिट होता है और ना ही लॉस होता है. हैंस ना प्रॉफिट इक्वल्स लॉस इक्वल्स प्रॉफिट पर्सन इक्वल्स लॉस पर्सन इक्वल्स टू 0. So that is one short video. I'll be posting such short videos in the coming days also. Thank you.